So what we're going to cover is file I/O, and we want to do it two different ways. One is using object output streams and object input streams, which let us write an entire object out at a time. And then there's also a way where you can just read in individual pieces of data, just like we've been doing with the scanner class. Read in, a next int or a next float, and we can write out, almost with a print statement. So there's two different ways of dealing, or two different ways of file I/O that we're going to concentrate on. Now this book covers all sorts of different ways, channels and buffer streams and this and that. So really, we just want two different things. And there's an example of the first way that we're going to talk about it out in our notes section. If we go to notes and examples from prior semesters, there's one called sample file I/O. That one shows using a PrintWriter, which is the way that you read the data, you write the data individually rather than as an entire object. Then there's another one called binary file I/O, which is where we do an entire object at a time. So those examples are out there, and we may use them while we are doing this. So I'm going to make a new project, and I'm just going to call this file tutorial. And what we want to cover, let's put our comments up here, is using a PrintWriter to write to a file, and then using a FileReader and a scanner to read from a file. And the reason that's cool is we already know how to use a scanner. So it's just going to look a little bit different, kind of like when we were doing C++, we could use the same stream notation to read either from the keyboard or from a file. Kind of the same idea here. So those are the first two topics we're going to cover. Then we're going to cover using object output stream. I'm not capitalizing it correctly. And object input stream to write and read data in an entire object at a time. So there are examples of using PrintWriter out in the PowerPoint. You can just do Control F on the Chapter 16 PowerPoint, look for PrintWriter. Kind of a strange example, HTML file generator, but it shows us everything we need to know. It shows us how to create the file. They go to a lot of trouble messing with getting the file names and doing stuff like that, and eventually they get around to actually creating the PrintWriter. And we're not going to necessarily do all that. Now, the reason that we did the things in the order that we're doing them is you have to know exceptions before you know files. And the reason for that is that file I/O, all the file functions will throw exceptions. And worse, they require you to add exception handling before the code will even work. The exception handling that we did already, the divide by zero and the failure to parse correctly, that was optional. We didn't have to add it. The code would still compile. Java's assuming, well, you could be handling this in other ways. You could just be doing an if statement to make sure you're not dividing by zero or stuff like that. But this stuff, writing to a file and reading from a file, is so fraught with errors that really we have to add the exception handling. And so there's really two kinds of exceptions. There are checked exceptions. Those are exceptions you have to handle in your code or it won't even compile. And then there are unchecked exceptions. Now, unchecked is a bit of a misnomer. It just means they don't force you to check it. It's optional. And so our last assignment dealt with unchecked exceptions. Example, math errors. Divide by 0, parse, double, or whatever, parse int, data conversion errors. All of those are unchecked exceptions. You can write your code, and if you don't add the exception handling grade, it might blow up. But FileIO does checked exceptions, so we will wind up having to add exception handling to our code as we go along. Okay, so I'm going to rearrange the order of these notes, put that above here, and now I want to use a PrintWriter to write to a file. Rather than go follow the example that's shown in the book of that HTML reader and writer, I think I'm going to go look at my own example. This is that one that says the April 20 FileIO example. The syntax for creating a PrintWriter, not that you can see this is way too small. Is you declare it like this, PrintWriter, I'm just going to call it PW. And it is a class. We're going to have to add the import for it.
Is this scripting?
This is Java.
Oh.
Yeah.
This looks really different.
Yeah. We want to create a new PrintWriter. So PW is equal to new PrintWriter. We have to give it a file name. I think I'm going to create a file name variable to store my file name in. So string file name is going to be called pw.out for printwriter.out. That way I don't have to keep typing stuff in, and if I want to print an error message involving a file name, I have it there ready for me. Now I'm already getting an error. What have I done wrong? Okay, if come over here and it says unreported exception. It must be caught or declared to be thrown. Now if you come over here, it gives some options. Add throws clause. That's a really bad way to handle it. That's just saying, okay, main, I'm really not going to handle it. If you get this error, you throw it somewhere else, and it's never going to get handled. Now that does make the problem go away, but it's not good programming. So I'm not going to click that error and choose add throw clause. There's surround statement with try catch and surround block with try catch. I'm going to choose surround statement because we don't have a block of code. And we can see what it does. It went ahead and fleshed out. It put the try around it. It put the catch there. And then added some business here about displaying the error message. I don't like that. I don't want to use the logger class and so on, so I'm going to delete that and just print my own error message. System.out.println file not found, and then print out the file name. Now I'm probably not going to get that error because it's not going to be difficult for it to open a file name pw.out. But if I refer to a drive letter that didn't exist, something like that, then I might actually get an error when I run it. There is no Z drive on my machine, I hope. So it should blow up. It says file not found. So the exception was actually caught. I'm going to take that Z colon out. I did want to see this error being caught. So I'm not liking this error message much because it says file not found. Of course the file's not found. We're creating a brand new one. So I'm going to change the error message to could not create file. Now when I run it and it's trying to access a non-existent Z drive, it says could not create file. That's enough information. Now I'm going to take that Z colon backslash out. Okay, Now you always have kind of a design decision to make here. You know, how are we going to handle our errors? Are we going to catch an error and return out of the code as soon as possible? I think what I'm just going to do, and this, we may wind up with some nested try statements here. We'll see. No, I think it's going to be okay. We have our PrintWriter. We can print to it as easily as we've been using system.out.println. I can do pw.print ln, and I can put a word in, red. pw.println, and I can print an integer, 1, 2, 3. Or make it a double, .456. And then let's close the file. We've written 2 things out to it. Really, we probably ought to write more, but this will do. pw.close. And we want to close the file just so that we're not hanging around leaving it open. The more quickly you close your file, the more quickly it could be backed up by a backup operating system, or the file's not locked so that you're the only one who could access it. There we go. So when we run this, hopefully it will create a file called pw.out, and then we'll be able to find it. I'm going to change the name of this to pw.txt because I can open txt files with Notepad. So I'm going to change that to pw.txt. I'm going to run it. It says build successful. I should have actually put some kind of print message saying that the file was written to. That would have been a nice thing to add. System.out.println. Finished writing plus file name, like that. That way, at least I know it did something. I'm going to go see if I can find that file with the Windows search, pw.txt. And here we go. It has the data that I just wrote to it. I printlined red, I printlined 123.456. If I want to use printf instead, I could do that. Like printf, %.2d, all of our favorite stuff like that. Or not, because this is a double, and I use d, which is for printing integers. %.2f, I always make that error. And it's .2, not 2. There, just filling that with errors. Okay, that's the correct version. Finished writing pw.text. If I go back and I open it again, that's the old version of it. There it is. It rounded it to 2 decimal places because that's what my printf said. So writing to a file with a PrintWriter is as easy as that. Anything you could do to display on the screen, you can just, with a few lines of code, creating a new PrintWriter, and then adding pw in front of everything, or whatever your variable is called, rather than system.out, you've written your stuff out to a file. So just to keep things kind of separate, I think I'm going to move this code into its own method. And I'm going to want the method to return true if it succeeded and return false if it didn't. So I'm just going to modify this a little bit. I'm going to, I could use that refactor thing that we've been using, but I think I'll just roll my own. I'm going to grab all of this stuff, including the line that says PrintWriter, cut it, and I'm going to go add a new method. Public static boolean pw for PrintWriter write file. And we're going to pass in file name as a string. And then I pasted everything that I cut there. If it all succeeds correctly, we return a true, else we're going to return a false. Realistically speaking, we shouldn't just be hard coding the word read and that number in there. These ought to be passed in as data elements or something like that. But I'm going to leave them like that. Maybe I'll do just a little bit of cleanup. I'm going to make a string called S, and it's going to equal the word read. I'm going to make a double called D, and it's going to equal that 123.456. And then I'm going to write my string out, and then I'm going to write the double out right there. Alright. Now I made all those changes, but this code is no longer going to work because I don't have a call to PrintWriter file down inside of main. So that'll be the next thing I add. We don't have a call to that function, but I'm going to build it and run it just to make sure I don't get any error messages. And it says build successful, but we don't see our finished writing message anymore. We got to go back down here, and now inside of main, I'm going to call PrintWriter file, and I'm going to pass that file name into it. Then run it, and it says finished writing pw.txt. I'm sure that the file is correct. pw.txt. Click on it, open it. There we go. Or same thing. And like I said, really we ought to be passing this data in to the function, but I'm not going to modify the function further. Okay, we have done this part. Use a PrintWriter to write to a file. Done. So now we're going to use a file reader and a scanner to read from the file. We want to open that file we just created, read that data back out of it into two variables, and then print that data out. So why don't we create another function called read file. It's not really PrintWriter, but at least it'll match the other one. It's a file reader, so we could have called it something else, but read file, file name. And we're going to need to add that function. So up here I'm going to add public static boolean pw read file. We have to pass in the file name. I think just to get it to compile, I'm going to put a return true at the bottom of it. Okay. So to get that to work, what we're going to have to do is declare a file reader and then declare a scanner. The scanner is going to look just like we've done before, except we're not going to pass in system.in. We're going to pass the file handle in. So, FileReader FR. FR is equal to new FileReader, and let's use our file name. It's complaining that it doesn't know what a file reader is, so I'm going to click and hope that it says add import. It does. If it didn't say add import, if it only said create class, it means that I have a typo. And now, again, it's saying unreported exception, file not found. So I'm going to click on it and do surround statement with try catch. Same situation. It added a try, it added a catch. We're being forced to implement this stuff because it's a checked exception, meaning that the program will not even compile without us doing this. And if we catch the exception again, I'm going to do an error message, could not open file. plus file name. Now we're probably not going to see that error message unless we change our file name variable, because we know that file does exist. We've been opening it. I'm going to add a return false here, because if we catch an error, I'll tell you what I'm going to do instead. Why don't we make a status variable that we can return, and Boolean OK. I'm going to set OK equal to false, and the only time I'm ever going to set it equal to true is after we close the file and we know it's done. And so down here at the bottom of it, I'm going to do return OK. Right now it's always going to say it's false. So let's add that. Boolean OK is equal to false. And at the bottom we will return OK. That's just our status flag, which we will set to true when everything works. So after this, before that, we need to do our return OK. We need to return our flag. All right, we have our file handle, we have our reference, but we don't have a scanner yet. So we're going to do scanner. Is equal to new scanner, but instead of typing system.in, nope, instead I'm going to pass in that FileReader object. Right now it's complaining that it doesn't know what a scanner is, so I'm going to add the import for the scanner. Then, since I have the scanner, let's use it. The format of our file is a string followed by a number. So let's do string data double D. Data is equal to our scanner.next. That'll read that string in. And D is equal to sc.next double. As easy as it was reading in from the keyboard. We've got our data, so I'm going to do I'm going to do fr.close. We're going to close our file reader, and that's giving me an error. Unreported exception. It's a real drag that offers the option of returning an exception, but by the time we get here, I'm going to go ahead and set the OK flag equal to true. We've read our data. We're good now. If the operating system decides it is not going to let us close the file, then in reality the file already has been closed by the operating system for some other reason. But I am going to have to add a catch, another catch statement. So after my .next and my next double, and I set my OK flag to true, it thinks that fr.close is liable to send an exception. So I'm going to click on this, and we're going to do add catch clause. And if we look down here, then now it has added another catch clause. Now we have two catches rather than just one. I'm not going to even print an error if that happens.
So do we do the surrounding or the add catch clause?
There we go. So why did I comment that out? Because this error is so unlikely that I don't think we need to be notified about it, because if the operating system has trouble closing the file, that probably means that the disk has been disconnected and the operating system has already closed it anyways. So, all right. If we get to this point of that fr.close, let's go ahead and print out our success message, system.out.println. Read from file name. And let's print out the two pieces of data we read, data and D. So system.out.print f data equals %s, and then that number we wrote is equal to %. Dot to f, and then a /n. And it looks like it worked. I ran it. It said finished writing pw.text, and then it said read from file pw.text, and the two pieces of data that we read have been displayed. So that's it. That's how to use the PrintWriter and the FileReader. We could do a much better job of commenting it. Since my text is larger than yours, I can't get all this to fit on the screen at one time. So I will upload these two things as well. But here's our write file function. It's a little bit shorter, fortunately. We create our PrintWriter. We use printline and printf to print to it. We could use any kind of print calls we wanted to. And then in order to read file, maybe I can condense this a bit. Put our braces on the same lines. There we go. Here's our 2 bits of data we want to read, string data and double D. Now that we have the file open, we want to read our 2 bits from the file. Now we're done. So set our return flag to true. Close our file, print out some good stuff. That's the top half of the function, and then the rest of it is just some error handling. Printing out could not file, open file. I think I'm going to go ahead and uncomment out that error and make it just say unexpected IO error. That's just what the user wants to see, unexpected IO error. Fill their hearts with terror. Alrighty. Couldn't quite get it all on one screen, but you know, here's the top part of it. Pause it, ogle it. Here's the bottom part, and then down here inside of main is where we actually use those things. Let's change the file name between the call to write file and read file, just so that we get to see what happens if the file doesn't exist. So file name is going to now become something that doesn't exist. I don't know, .txt. So when we run it, we finished writing pw.text but could not open file. Now my error says could open file. I need to correct that. But there we go. So we proved that the error handling did handle the situation of the file that we're trying to read not existing. Let me go correct that error. Could not open file. Alright, I'm going to stop the video here and start another one. So the first of these 2 videos will be for, reading and writing in the form of a text file using PrintWriter and FileReader. And then the next video coming up will be reading and writing as an object file.